All right, so how's everyone doing today? Just vibe check. Tired?
I'm a little tired. Yeah.
I mean, well, I hope I can wake you up with some presentation. Today we're gonna be talking about hosting web applications. So if you guys ever built a website before, you guys will have a question on hosting it. Most times you probably be like just doing it like on localhost or like on a local development server. But you actually want to host this, there's a lot of different ways to do it. And I want to kind of go over the main ways that we can think about it, or the main options that we currently have. And like just go over one example with in a demo format of AWS, hosting with AWS in Vercel. So today we're hosting the backend using serverless functions on AWS and Vercel for the front end. And I'll kind of go over what all that means in a second, because those are large words. So we'll kind of go over that. So just a quick background. Who am I? My name is Jeffrey. I am a senior EC at UT, and I have a few experiences, working in SWE. So, take my word for it. I think I've worked in SWE, but other cool things is that one fun fact about myself is I taught myself how to like basically write left-handed. Um, for like an AP test, or like I was prepared to do that for an AP test, so I could like, since my hands would like be really tired, I could just switch hands. So you guys want to know that's like AP Euro. It didn't really work too well because my speed was really slow on my left hand, but I am in that case ambidextrous, you could say that. So one thing I can actually do is first I should share screen because that should have been done before. And then I'm representing TPEO today. We're just an organization around campus that builds projects for software engineering with product engineering and design. And I also host a few like lessons, and I have two courses. We have a course in the fall about full stack development, and a course in the spring about JavaScript that's currently going on. If you guys want to learn more about like intro to programming with JavaScript, you guys can head in Thursdays every week at 6 to 7 at GDC 5.304. And we like to build a lot of cool things, and check us out on our socials. So today we're gonna kind of go over like the agenda, what we would talk about like briefly what front end and back end is, how hosting works, the trade-offs between hosting a front end divided or coupled together, and then we're gonna have a demo with deploying a front end React app and the Express backend. So first of all, what is a front end and back end? Does anyone know, by the way? Like anyone heard of these terms before and don't know what, or like kind of have an idea what they are?
Front end is like IDs that the interface user. Backend is actually behind the scenes.
Yeah. It should be pretty it's pretty intuitive, I would say. Backend is, the part of the web that you cannot really interact with directly, and the front end is the web that you can interact directly. Now that's technically not true because you can interact with a backend by calling API calls. But generally on whatever website you guys go to, interacting with the front end allows you the front end interacts with the backend, and we do so with that using something called an API. So here's a really nice analogy like I like to give often about front end and back ends and APIs, because those words might be a little confusing. So how do you guys order food at a restaurant? Kind of disclaimer, this is not like a restaurant that's like real, like that's a like online restaurant and whatnot. You're at a sit-down restaurant. There are a few things that you might need, or a few things that key components that you might think of. One is a menu, so you can actually understand what you can order, a waiter or like some server that like let's take your orders for you, and then a kitchen, or a way for the restaurant to make its product, whether that be like food, whether that be drinks, etc. Whatever restaurants kind of create, So this corresponds in web development to the user interface or front end, an API, and a backend. So we'll kind of go over very briefly about this equivalence between these three. Analogy is not perfect, but I think it's really, really good to just understand if this is the first time thinking about full stack development. So first of all, think about your menu as the front end as a menu or a user interface. So the front end is something that like allows you to structurally interact with your service basically. And like as in a restaurant analogy, having a menu allows you to basically see what's on the menus or see what's like the restaurant is serving, and therefore allows you to kind of make those orders or be informed with that. In many ways, this is very similar to how a user interface works on a website. You basically go on a website and you can start looking at the website. You see what information is there, what kind of interactions you guys can do. And this serves as a good front end, or this concept serves as what we call a front end. And of course, similarly to how a menu can have varying qualities, may not be up to date, for example, based on like some deals and whatnot. A good front end is usually pretty expressive and gives you guys enough information, and is also up to date and is pleasant to use, right? So with that, we can kind of go to what an API is. So an API is the middle point you can think about between a front end and a backend. We'll see what a backend is in a second, but an API basically understands a variety of requests that users can basically make. Similar to like how a waiter does this, right? So whenever you order food, you should go to a waiter. You don't directly go to the kitchen and tell the chef what to make for you, right? You go through like the waiter or some intermediary. Similarly enough, the API is something that allows you to do that on a website. Question?
Hey, I think someone wants the Zoom link. So if you could go to Discord, and once you have the link,
Sure, yeah. Come up with the link. One sec.
yeah. You just go to Discord, and then you can join it.
So where should I post this again?
In hashtag workshops, John had added you, I think, there.
Cool. Okay, give me a second. Hashtag workshops. Okay, cool. There should be a link. Can you guys just double check?
Yeah, I see it there. Thank you. Yeah.
So does this give you this should be it,
Yeah.
because I just use my personal my room, so.
No, that should be good. Thank you so much.
Okay, someone in. I just want to make sure that someone can get in for that. Just want to double check. Is that good?
I'm asking.
Yeah. Yeah, I just want to check that real quick. Because I remember making this with like my personal, and this is what I basically sent. So I want to make sure that lines up.
I can also try and just join it.
Oh, there you go. Anji is in my room. Hello, Anji. All right. So we left off at the API. So we kind of have a relation between a waiter and an API and what a waiter is in a restaurant. The waiter would like to be able to understand a variety of different requests. So very commonly, this is to provide like customers information on the menu, of clarification questions, handle like customer orders, and also know how to respond, right? So if someone basically like starts speaking gibberish like to the waiter has to know like, okay, this person is kind of insane. Let's ignore that. Or for example, if let's say that we have a lemon shortage for some reason. Let's say like global supply chains are not doing well, lemonade is expensive, and therefore we ran out of lemon for today. The waiter has to be able to mention, that certain items might not be available on the menu currently, or has been increased in price. And this is very similar, like, what an API can really do for you is, for example, if you go on a page that's something that for a resource that doesn't exist, they'll give you a 404 error. So this is very commonly seen in like web programming, where if you access a page that's not available, it will give you 404. It's very like the API knows that page just doesn't exist and will send you the proper page back. So it's very similar to how that works. And a waiter will also have to tell you, we're out of lemons, and order something else. So we like to think about the kitchen as the backend. The backend is a like culmination of all functionalities provided in a service. For a restaurant, like this will be really commonly done by assembling food orders, right? So this is what a restaurant generally does. This is their business proposition. Basically, you have a great dining experience, and you also have really good food. The backend will also like be involved in keeping track of resources. Most commonly, it'll be like something called a database. You guys ever used database in the past? It's very similar to how when a restaurant like keeps tracks of inventory orders. So in our previous example, when we don't have any lemonade, it will basically check, for example, that we don't have lemons anymore, and the backend will basically like, understand and like relay that information to the API. The API will basically return to the user or the front end that, we're out of lemonades or we can't serve this request, for example. This is kind of what goes on behind the scenes. So very crude simplification. In reality, there'll be a database. There'll be a lot more like, different services, caches, queues, and whatnot. But on a very basic level, when you're building an application, you need a backend which will basically like interact with the database, and with that you'll be able to serve requests persistently. So because you guys all know, if you refresh your page on your website, things will still like stay there. Like, why does that happen? Partially because that data is persistent. And how is it persistent? We use a database for that, commonly at least. So does that all make sense for everyone? Cool. So for hosting, we have to first think about that. Like, we really know like what a front end and a back end is. So there are a few things we really want to consider hosting. In our example, we had a back end and front end, but we also want to be able to host a database. And there are many different ways of doing this. I'll briefly go over how each part should be hosted in an application. So assuming that you guys have like a React app as a front end or an Express server as a back end, but these are just very common tools that you could use to build these front end and back ends. So in many ways, building front ends and back ends, there's many ways of doing that. So for a front end, usually what will happen is you would be building that application. It will give you HTML, CSS, and JavaScript. This is what is needed to be hosted, and they're usually put in a static build folder. So a lot of your websites, like currently, like online, if you're, let's say, building a blog, for example, is just HTML and CSS. This is very commonly known as what you actually have to host, right? You just have to have these files and host them online, and the files that you need to host are HTML and CSS, and JavaScript if your website uses that, right? So on the front end side, whenever you're building a React application, there will be commands that you could use to build your application and deploy that front end. And in any case, like any website or any like hosting services, that's what they do basically. They either ask you to upload a static file or send a repository where they'll run the commands that they can use in order to get the static build file. So for the database, usually there are multiple ways of hosting databases. You can do it locally. You can containerize the information with something called like Docker. You guys ever heard of that technology in the past? And upload it to a server that can run that database. Or there are also services online like Firebase and MongoDB that provide you, or MongoDB Atlas, that provide you a database online hosted already for you. So you have to worry about that. So what you have to worry about is actually authenticating and accessing that database on your backend, right? And finally, we have a backend server to host. What will this include using? Well, we all know that like our backend will try to include the API routes and logic for database interaction. And there's usually two ways of doing it. One is hosting a server and running that backend application as a web server on that server. Or you could use something called a serverless application, which is what we're going to kind of approach. We'll kind of go over what that means in a sec. And then again, if you wanted to also like containerize it, that's also an option. Containerizing is basically being able to it's basically having a contract for a lot of computers, a common platform that can run certain applications. So it handles all your dependencies for you. So for example, if I run let's say if I run my backend on my Windows computer, if I put it in a Docker container, it can be ran on any platform with that technology, Docker, on it. And this is just done because it can standardize a lot of the deployment process for backends. So this is a very common thing you'll see when deploying your application. Does anyone have any questions on that? I hope I explained that pretty well. Yeah, we'll be using Docker implicitly for our demo. Like we won't be like installing Docker specifically, but it'll be used, it'll be bundled using the serverless, plugin. And this is to say that, you can, with a lot of this, like all three, like front end, back end, and database, there are many different permutations of how you can host each one of those. You can host the back end, front end together, which we'll kind of go in a sec, under the same page, because the backend is basically requires to be a server, and the server can serve your files. Or you can have a hosting service for your front end which is what we're going to be using right now, which basically takes your repository and builds a static build file, and then like exposes it on a URL. Question.
Yeah, quick question. So for the demo, which one are we sort of going over, all of them? Or...
Yeah, so we'll be mainly hosting the front end and the back end, because that's just the basic things you need to have for a hackathon mainly. Database also, like, we can also include that later. But the idea is we'll be using a AWS serverless solution for our backend server. So we'll make the functions that we write or API endpoints available deployed on AWS. And on the front end, we're going to deploy using Vercel, which is a deployment tool on the front end side that we could use. And yeah, and then we're gonna be able to do some configuration on GitHub in order to let that happen. It's really easy, honestly. I think the hard part is probably gonna be AWS overall. So there's one thing that left, I think, like should be mentioned whenever you are like making any like application, which is like files. A lot of your projects are gonna have like a user uploaded assets. So this will be maybe very, very commonly is like your profile picture, for example. Any like files that you upload on an application should be like downloadable, for example, like for a lot of our applications. So there are a lot of different ways you can do this. Generally, like not all projects will have file storage hosting, but a lot of different services like backend as a service services like Firebase will have like storage for you, like provided as one of the services you can access. Also AWS S3 is another place you can do file storage, and they expose you a really nice API you could use in order to access that online service. But there's generally 3 different ways of actually hosting this. So if you're using your own server, you can store your assets on your disk. So imagine you have a server that's going to serve you requests on your images, for example. Whenever someone uploads an image, you save that image to your computer or to that computer, and it will serve it back to you. That's one way of doing it. Another way is to store files on a database, which isn't very recommended. I'll actually post that question in a second. Like, why would you do that? Why would you do that? Or you can, as we mentioned before, store your files on a hosted service such as AWS or Firebase. So, you guys, based on all like your knowledge, why wouldn't we want to host files on the database? Security could be one reason, yeah. Your database. Well, actually, like that's not the main reason, but like security is something you consider whenever you are hosting anything. Anyone have any other thoughts? Yeah.
Isn't it gonna like a lot of it? Let's say your files may store a lot of information, right?
Yeah.
So the database will have like a lot of information in it, and so you're gonna have to have like a lot of like room for that.
Yeah, I think you got a point. Yeah, it's like the storage is like the level of storage is kind of different when it comes to database and like your file system. Think about the difference between like your memory and disk. So like most database applications are loaded in memory, for example. And if you're just like in the store like that data in memory, it's going to take up a lot of like space. Another thing is data, like because we're working in memory, for example, it's very easy to do data manipulation, like manipulation of data types. But as you said, files are, like can be really long. They're very high in variance. So it's not like you have like a number that you can like basically sort by, for example. So databases are really good at like, working with structured data, whereas files are usually not very structured data. And if you guys ever taken like an OS class, you probably know that all files are just, binaries, like zeros and ones in many ways. At least the binary files are. I mean, text files are also like zeros and ones, but can be readable. But a lot of the files are basically unintelligible to the the computer when like unless you have a program to read it. This is the reason why you need like programs online in order to read your PNG file, like for example, or like launch a PowerPoint presentation. And like a database doesn't have those programs on it, so it wouldn't be able to take advantage of the structure of the file. So most cases you would not want to like store files on a database as a result. Does that make sense for everyone? Like this is kind of like a rookie mistake. I know because I've done that before when I try to like, I was like, where do I store my files? What can I just, send a stream of base 64 encoded string to a backend and then just have that stored in a database. And I realized that was not a very good idea because the database has like limit storage, and depending on the size of your file, you might not have enough like storage in the database itself. So many like databases like MongoDB give you like a 500 megabyte limit for like the free plan, and if your files are like 1 gigabyte, you're never going to be able to like scale that way. That makes sense. Okay, so we mentioned a few ways of hosting the front end and back end in the few minutes ago. I want to kind of clarify what those means each time. First of all, the traditional way of hosting a web application is to host the back end and front end together. So how this will work is that you have a front end application, and this front end application is just a bunch of files, right? As we mentioned before, it's just a bunch of static information that you can have. Your backend is going to be integrated with a server, so it's going to be like a web server. And your web server serves your, can serve requests, as we mentioned with the backend, but you can also serve files. So you can basically tell the backend, hey, I want to serve the front end files, and whenever I publicly access a website, I can call the backend, and the backend will serve the files back. That's usually how things actually work, and in most cases, this is like the very baseline on how things work. All your files are going to be stored in, let's say, a server somewhere online or on your computer. And when someone wants to access those with a protocol like HTTP, they'll be able to serve that, file back. So this is a very common way of doing it, and it's very nice because one thing is you don't have to deal with cores. So who here has heard of cores before? Yeah, that's a lot of sleepless nights, right? So basically, cores is the idea whenever you guys build a front end and back end application, the website that you use generally like web browsers are like not very safe generally, and like one thing that you can do in order to make browsers safe is to kind of limit where you can call requests. If that makes sense. For example, I can go on any website and literally just make a fetch call to you. So if I loaded any JavaScript, for example, I can go to the console right here and call fetch on let's say something like Google.com or something like that. And if I can write a script basically and have you click it, you'll be able to access certain resources, which can be pretty dangerous. So cores is a way for us to mitigate that, which basically tells you on the back end and front end, hey, what kind of where can I send my requests, right? And this is specifically done for the web because web's you can program, it's very common to be able to program for the web. It gives you a lot of granularity, right? Because you can write your own HTML files, for example. It's very, very open. And as a result, it's very easy for you to also write programs that can be malicious, right? So cross-origin resource sharing or cores is a mechanism that prevents that. And if you ever built a project before, you realize that you can probably call, if you create a backend, for example, you can call that backend really easily through any tool. But when you try to access it through a browser, it'll give you an error called cross-origin resource sharing or something like that. So I can kind of give you guys an example of cores. Cross-origin resource sharing. Yeah, using this console may allow hackers to impersonate you and steal your information with the attack called self-access. So this is actually really fun to me. I didn't actually expect this, but this is one way you could actually steal information by making calls. So the idea would be, since your front end and back end are hosted on the same URL, in the first case, there will be no way for hackers to basically or at least if I'm making a call to my account or my website, it will assume that it's safe. So anything hosted on that website URL will be safe. And if I call those requests to my URL, it'll be safe. For my backend, for example. But if I host them separately, this is not the case where you host the front and backend separately, and you will have to deal with cross-origin resource sharing with that. I'll kind of give you guys an image on what cores is, how to better explain cores. This is something you might really see very common, which is just access to fetch at something has from origin something has been blocked by cores policy. Access control allow origin headers present, but not allowed. So a very common example I give is, let's say if you have a website that looks fake, let's say, it says like, click here to like claim your like buy your MacBook Pro or something like that, right? You click on that website, and what it'll do is it will redirect you to a page that looks like Apple's website, and then it'll ask you to insert your information, and then like have it be able to send a request to Apple's website saying that you ordered the MacBook Pro, and to kind of spoof it and add a like malicious address, for example. With core policy, Apple will basically say, unless my request has been made from my website, then there's no way that anyone can make a request to my server. So that's TLDR, what that kind of means. So I know that was a small like tangent on that, but I wanted to make sure that makes sense. The second option is to host a backend and front end separately, as we mentioned before. Very commonly, you can use AWS to host your backend, and then have your front end be hosted by one of these other options like Vercel, Netlify, and GitHub Pages. This is a very common way you can host your website. If you ever hear about like something like WordPress or like GitHub Pages, it's a very common way of hosting websites. And this will be having a backend and front end hosted separately, because generally you won't be able to have a backend involved when you have a GitHub Pages account or on WordPress. And the reason why this is because those websites are generally made for more static sites where all the logic is contained on the front end. And it's a different paradigm, but also like something where essentially, it's expensive to host a server basically. And there's a reason why it costs money. A lot of services cost money in order for you to host, like allow you to host your website. Whereas if you're just, storing a file, it's not as expensive, which is basically what we're trying to take advantage of here. When you're, if you're trying to host only a front end, it's cheaper usually.
Oh, by
Yeah.
the way, Heroku doesn't have a free tier anymore.
Yeah, exactly. So we're not using Heroku this time.
Oh wait, I just saw Heroku 10. Sorry.
Oh yeah. So in the past, yeah, it says Heroku is an option to host backend, use the backend to serve the front end. We used to do that, but right now it's like Heroku has changed their plan. I'm pretty sure that they still allow it to be free for students, but I haven't had any luck with that,
I
recently.
think another replacement could be Replit.
Replit?
Yeah, I think they do free hosting, but I don't know like how like easy or like stuff. I think it's pretty good. I don't know. I haven't tried it yet.
Got you. Yeah, I mean, there's a lot of these services that allow you to host like traditional servers, but usually it's more expensive because if you have a server, you have to provision it, and it takes up hardware resources, which is a reason why we go into serverless. This is something you might hear a lot of times when you're hosting and having building an app in general, whether or not you should use a server or not. The reason why we think about this is because in the end, what you want is to just provide a service, right? You want to be able to like have an API and just a website. You don't want to have to think about, installing Linux on your computer and like, having and then like running a web server and, do all this kind of nonsense. In many ways, a lot of companies have found like ways for them to use their servers and have you like be able to access your server and their servers in an easy way and make that as a service. And so when you hear about the term serverless, what it actually means is there is a server, but it's just not like you don't see it in a way. And the idea, the reason behind this is because like it's kind of as a like a auto scaling kind of configuration where you have your application be put as like functions and have them be run on certain servers, but they only are run when user traffic comes in. So Amazon has created a really nice technology, or has integrated a very nice technology called serverless, which allows you to basically use as many compute resources as you need at a certain time, and deallocate before. Now I know this wasn't very clear, but traditionally you have a server, and that server has to be always up in order for you to run your app. And what Amazon does basically is saying that, well, sometimes based on how much usage that you've seen in the past, we might allocate some servers for you. And if you have no traffic at all, we'll deallocate your service so that other services can be used. So this basically is a very effective way of using bandwidth, right? So it's like, does anyone know like the difference between like telephone lines and let's say like your wireless systems right now, or your Wi-Fi? So the idea is that on your phone, they traditionally they give you a fixed bandwidth, basically. So like they give you a fixed bandwidth of a line. And no matter how much bandwidth you're using, like technically, they'll just give you a fixed one. So this is the reason why it's like very reliable whenever when you call on your phone, unless of course you have any like interference. Compare that to, let's say, on Wi-Fi. You have a lot of people using their Wi-Fi at the same time. A lot of people are multiplexing on your Wi-Fi, and as a result, your Wi-Fi speeds can go lower. You can get less bandwidth because of so many people are using it at the same time. And so this is kind of like an analogy I could use between server and serverless, if that makes a little more sense. Does anyone have any questions on this? Because I know I went through this fast and maybe I didn't explain it too well, but. So here's a diagram. So a client will basically call an API, and the API will be using this something called AWS Lambda, which is a serverless provider, and it will basically take those functions and activate them, and then send back the data that you need. Okay, cool. So we're gonna have a demo for everyone to kind of follow along with. There's two parts to this hosting. This one is going to be so I'm going to send you guys a link to the GitHub. Everyone on Zoom is going to get a link to the GitHub basically, and also on Discord. So you guys can follow it over here. The speaker channel is not right. Let's see. Workshop. Okay, so this is like a hosting demo, like branch I've been using for quite a bit. It kind of goes over where we just went, and it will kind of give you a better idea on how to host an application. So I'll briefly kind of go over the code, which basically goes over most of this. You have a React application, so it's something called My App. It's just a very basic React app. Anyone here not used React before? Like, raise your hand. Anyone has not used React in the past? Yeah, so basically you'd be like, running a command called create React app, and that will create an app for you essentially. And when you have that available, you'll be able to code like the app locally. And afterwards, if you want to deploy something, you have to run a build command that lets you build everything. So we generally like to separate the front end and back end code in our application. And this is just to show that my app is the front end code part of the application. And then on the outside, this is the backend code. So this is basically what we have for our backend server. So this is, as you can see, we have our basic Express package. So this is what we commonly use for a backend on JavaScript. It's called Express, and that will allow us to basically build an app. I made a very simple app right here that just basically returns a JSON message that says like sending hellos. JSON is basically this way that like a lot of people on the web communicate with. Just that's a TLDR. And basically what this app basically does is, whenever someone calls a GET request on hello on our website, we'll return this like JSON object. Very simple, right? Like, I think hopefully that makes sense. And then we'll also basically say, well, for the serverless stuff, we'll export our app right here using this syntax right here, and that will allow us to basically port our server onto like serverless, and then when we run some commands, it'll do its magic, basically. So there's a few things that you need to have in order to make this work. So everyone go to your terminal. If you guys are Mac or Windows, make sure you guys have a terminal, and make sure you guys have Node installed. So does anyone not have Node right now? Don't worry, we can spend some time to help you guys install if you guys don't have time, or if you guys don't have Node ready. But basically, if you have Node and Node.js, what you need to do is basically install a few different packages. So here are some of the packages that you would like to have. npm install like serverless. This is going to be the main package that you're going to use to like interact with AWS. So I actually have an AWS account right now, and I can probably access it right at this moment. Not voice cloning, that's a different project. So does anyone not have an AWS account? Probably not, right? Yeah, this is probably gonna take some time to set up, but I'm gonna kind of go over like how I actually set it up overall, so you guys can replicate it. Basically, you just have to create an account. It's just like any other website. Just type in AWS, and then put the root user, and then give your email. I'm just gonna use my email, jltexas@utex.edu. So on the console, there's one thing that you really want to look at, which is basically just like Lambda. These will give you like certain functions that you can do, you can use in order to this is gonna be kind of where you can access all your functions and things that you've deployed. As you see right now, there's no functions because we haven't deployed anything yet, basically. But what I want you guys to do is basically create an account on AWS IAM. So this will allow you to access resources and users. So what you need to do is go to users and like create a new user, like by adding a user. So let's just say let's use Aditya for some reason. So, and then we'll attach some policies. Now, basically, there's a lot of boilerplate when it comes to Amazon because it is a really like big, like, and like powerful application. But basically, I outlined these are the kind of permissions that you need your users to have, any user to have. So we'll just basically copy paste this. So first thing, let's get the Amazon Gateway Administrator. This is one thing. Okay, and then the next one is going to be S3 for access. So that's another one. So that's the second one already. And then 3, AWS Cloud Formation Full Access. So these are all services that like you would like your account to have, so that so that users can like uniquely identify you, or Amazon can uniquely identify you on your computer, so you can actually like call requests to these services. Basically, this is the third one right here. This is AWS Lambda for logs access. And it might not be very good practice to give full access for all this, but as for a demo, this is the quickest and most like effective way. Whenever you are building your applications, like be sure to like know what like each user can do by specifying the access permissions accordingly. But in our case, we're just throw caution out the window in order to prove a point. So we'll create a new user, and as a result, here's my new user. So Aditya has been created. Very nice, very nice. And what we want to do basically is go to, I believe it's security credentials, and create an access key. So we'll choose something like application running on an AWS compute service, and then click I understand, and you'll be able to create your key. You just say this is just like the test key. And this is the key that they generate. So make sure that you have this in a very safe place. So what I'm going to do is I'm just going to, make their hosting, CV hosting. I'm going to create a new file. Just like, I'm going to delete all of these, like, of course, afterwards, because like, I want any of you guys using my AWS keys. Not that you guys would. No, not this one. Wait. So you save that. And what I would like to do with here is basically what I need to do is I need to configure my serverless. So what I need to do is, first of all, I need to install the serverless right here. npm install-g serverless. So I already have it installed, so it's not going to take too long to do. And then I need to like configure my serverless using these credentials right here. So what I'll do is I will have to type in this command. You guys can copy it as well. And then basically fill in the public key and private key as the ones that they gave you. So I'll just do, oh, I just forgot we just did that. And since like I stored my credentials there, I'm gonna basically get them from AWS. So here's my access key. So key public and secret. Then this is default is already configured in that. So basically what this is saying that SLS log out, I think that's what you do. Let's do that. Let's do -O. Yeah, so basically I configured my account by running this command. I already had another account on this, so I just created a new one and configured the key with this. Does that make sense why we need a key to access it or everything? So the idea is that we're basically going to be trying to use AWS. So AWS is a service that gives you access to your allows you to access compute resources and does do all this serverless stuff. And what you need to do is basically like serverless, the command line tool that we just use by typing SLS needs to know which AWS account to associate you with. So AWS is like basically will give you some keys that you could use in order to do just that. And then so you just have to run the configuration, which basically whenever it deploys something, it will use those keys and know which account that you're going to be accessing. It's just like if you ever go online and you go on a website and you log in with a user and password. Very similar. You just provided a key, and this is a form of authentication. One of many ways of authenticating on the web. Cool. So since we have that done, what we're going to do is we're going to basically clone my repository because we haven't done that already. Do that here. So for everyone following along, you guys can do that. Clone. And then you go into hosting demo. There's a few things you guys have to do in order to make sure this works. So first of all, let's run the front end. So let's go to cd my app. You run npm install, which will install the dependencies of the React application. Basically, you're using you have a project and you want to be able to install the dependencies of that project. There's just if you work on a Python project, there's requirements.txt. If you're in Java, you have to download a jar and import that. In JavaScript, you have to run a command, and that will just allow you to have all those libraries installed for you or imported for you. So to make sure this works, we do npm start or run start. Cool. So right now, that this should be our website. Is there a development environment? Right now, it says default text because there's literally nothing there yet. And we're not going to build too much. It's just showing how you can deploy this. So whatever app, however complexities you add to your front end, it shouldn't really it should be independent of hosting, right? So we have that installed. Another thing we have to do is to install the the backend information. So we have we do install again right here. So this is the backend. So the structure of this this app is basically you have your backend is in the main directory, and then your front end is in one directory below that in my-app. Okay, and then what we have to do is, since we installed that right now, we want to test if something if serverless kind of works. So what we'll have to do is do SLS. There's a command you can run called SLS offline. I think it's called run. Okay, one sec. So when you're developing your application, you want to be able to see if it works. So SLS offline start. Okay, so that's what it is. I hope that works. Let's see. So if you guys can see, I run that command, and then if I go to localhost 3000, it should access it. So type in localhost 3000, and then it says cannot get, but we need to /hello because that's the URL that we access. And then, as we said before, we have this message sending hello from before. Right there. So we have this message, which is exactly what we expected, the JSON object to be recovered from that. And what you wanted to do with that is, well, we want to test that this actually works with our front end. So we might do something in a second. let's open up a new terminal and then basically cd back into this. So I'm just do here. Yeah, we're going to do my app, and we're going to do npm run start. So we're going to run the like localhost our front end app again, and we're also going to be running our backend app. So it's SLS offline start, and I think you have to pass it a configuration to allow it to be run on a different port. So this is just a command that you would use to run it on port 5000. And hopefully we reload this page. Let's see, fail to fetch. Has been blocked by course policy. Interesting. So let's take a look at our code right now for a second. We should try one more time to see if that does anything. So this is the elusive CORS error that we mentioned before. You guys can see it. It basically tells you that you can't access the website for some reason. Because like you're hosting one on localhost 3000, the other one on 5000. So, but I hope I can access it with this. Well, it looks like we won't be able to access it right now. I'll fix it in a second. This should have worked, but yeah, access to fetch from origin has been blocked by CORS policy. This is very sad, of course. But we can try to deploy this on a like AWS. So, this should work for anything like so essentially what you have to do is you have to enable the CORS on the back end, which I think I already did before. But there's maybe one more setting that I have to like switch on.
Not work because it's allowed you to operate in 5000s, but we are on 3000. Isn't that the reason?
Oh no, so the front is on 3000, right? And you're trying to send a request to 5000, which is not the same as 3000, right? And therefore, it's a different origin or a different URL. So the web protects you from it by using CORS. But as a result, like it's very annoying because it's not very well like documented, not very well like it doesn't tell you the steps you need to do in order to solve it because there's so many ways you can basically solve it. But for us right now, we can just try to deploy this on AWS. So we ran the server locally by using the offline version, and now we can do SLS deploy. But this will take some time actually. And like I have a configuration for here. Let's see. It's called serverless.yml. So this has a lot of different like plugins and things that you can basically like look into if, in a sec. One thing you want to make sure to get right is that there is a, we specify the path or the URLs you should be able to access, the endpoints. The only one we provided was /hello. The one that we mentioned before that returns you this message in the JSON format. And that will be under path /hello. And so that's the main thing that you just take from that. And then index.server, that's just being able to access those functions. So in the end, we're basically like having a program, and we just want to like tell this configuration file in order to access your access those functions, right, that you have. Okay, so this will take some time. So in the meantime, what we'll do is we'll deploy the front end using Vercel. So we go on vercel.com, and Vercel is a very like really nice application that allows us to basically connect our GitHub and host our front end, basically. So give me a second while I do that. So I'll have a hosting demo ready right here, and let me just delete this because we want to kind of start from scratch, right? So I'm just going to copy this hosting demo to continue, boom, and delete my project below. Make sense? Like now that's been removed. So what we have to be able to do is what you guys will be able to do is go to the GitHub, and then this hosting demo. What you do is you click the fork button, and that'll allow you to create your own fork or your own copy of my repository, which in which you'll be using in order to deploy onto Vercel. This is the front end section, right? This is the React app that we see right here. We want to put this on the website on the internet somehow, and we'll be using this tool called Vercel that will host our front end for us. So let me just add a new project in order to do this, and then let's import hosting demo. And then we need to do the specifications on this, right? So what do we want to host? We want to host the front end. So go to my app, and it'll automatically detect that this is a React app right here. And if you see this, it means it has succeeded in detecting that. And then afterwards, we will press the deploy button. Now this will be queued up already. And in the meantime, we can take a look at our backend that we deployed on AWS. So if I actually click on this link right here, this is not local. This is local. It'll say testing, sending hellos. This has succeeded. Yes.
So before you said it was getting blocked by cores because it was from different origins.
Yes.
So now, why is it not getting blocked when they're doing that?
Oh, well, we haven't actually checked if it's been blocked yet. Because it only matters if you're running a website like this, this front end, basically. So as I mentioned before, cores only matters on browsers or on websites, right? If you directly access the website using the URL, you'll be able to access the website at any time. Or if you try to use curl or any tool in order to access the website, you'll be able to access the website. But if you use a browser, for example, then they might give you cores error and that's usually very tough to debug because it's very this, as I mentioned before, there's so many ways of doing cores. So as we see right here, we published the website to Vercel, and of course, I think the cores didn't actually go through somehow. Let me reload again. Oh, it did. Oh, you see that? It testing saying hellos. It worked. So I think that on locally there was some issue for some reason with the app cores. I think it's because of the way we were trying to deploy it using the serverless offline. It might not support cores very well. But as you can see right now, when I deployed this hosting demo Vercel app, I'm going to give this to everyone else if you guys want to check it if it worked. So here's the host of the website. And so what this is doing actually, it wasn't, if I didn't explain this because I don't think I did very well. Basically, I am sending a request to my AWS. So as we can see right here, this is the URL that your AWS gives you right here. And then this is making a request to this website. It will get back testing, sending hello, and we put it on the website. This is the very basics of setting, connecting any front end and back end together. Basically having your front end be able to call an API on the back end, have the back end send the data back, and then have you be able to access that data. In this case, the only thing we did was just wrote texting, sending hello, the exact messages that we had before. And if I want to change the message, I can redeploy and we'll reflect that. So I can kind of show you that's not just hard coded. But yeah, so we hosted our front end. We also hosted our back end using AWS. These are some endpoints. If you want to create some new endpoints for your AWS, you have to specify that in the serverless.yaml file that we mentioned before. Just follow this format. So if I wanted to add another URL, let's say /hi or something like that, I can just add it right down here and then add the function up there and it'll automatically connect it. Do you guys think we have time for that right now? Probably not, but I know the 1 hour has been up, but does someone else need to have this room after, or should I go over?
I don't know about the room. I can check, but I guess let me check first. Let me check.
Sure, that'd be great. So
I think it should be fun.
you think we're good right now?
Mhm.
Gotcha. Okay, cool. So that's basically been the demo. All the code is online. If you guys go on AWS, you follow the instructions in order to create a new user, get your access token, and then you should be able to access, with these configurations, you'll be able to access the AWS account with that. And in our case, we're just using it to use the serverless functionality. We're good?
Yeah.
All right, cool. Well, I think in that case, I think we can wrap it up. I think we're exactly on the dot. I'll take any questions, or if anyone wants to like do this themselves right now, I can kind of spend some time to help them overall, like set it up. So we'll take that. And anyone on Zoom, if you guys have any questions, let me know. Just go on my Discord. I posted this link on the Discord, and you guys can just reach out to me there. That sound good? All right, thank you guys for joining in.